In the previous lecture, we discussed about normalization, relationships, and ER model. Now, what is normalization? I told you that we try to reduce the duplication of data. We discussed types of normalization, first normal form, we discussed second normal form, third normal form. After that, what are the relationships? If you remember, in the first lecture, we discussed about different tables that in the database we use tables to store the record. So let me show you original database design so you can get a better idea of that, how our original database looks like. This is Oracle SQL in which we used to create data, or in which we used to create our database. So let's see. I told you that in databases, we used to store our data in the form of table. So let's suppose we have created the database for the employees of an organization just like this. So let's see. Let's suppose this is how we created a database by using SQL structured query languages. So let's see how we can display this data. To display the data, we also need to learn a language, SQL. So in advanced database, we will learn about this SQL language. But till now, we will discuss how we can create that database and how database is stored here. So after connecting it, the query will run here. So this is how the database is created in the form of tables. Now you might question how we created this table by using such kind of structure query language. We created this kind of table. So if you remember in the first lecture, I told you that the data is stored in the form of tables in database. So this is the table that will be displayed after storing the data. So this is how in practical, or you can say in professional field, the data is stored. So now just like here, if you remember, I told you about normalization. If you remember that the name Ahmed is repeating 2 times. So just to remove such kind of duplication of data, we use normalization. And now you are viewing this table. If I talk about the ER diagram, now the data here is present in the form of table. Now, if we want to present this data graphically, like which data is unique, what kind of relationship will be built among all of these attributes, for that purpose, we use ER diagram, entity relationship diagram. For example, this is an entity employee. We have gender as an entity. What is entity? Entity can be anything that have some attributes. Now, what are attributes? Attributes are the properties that can be used. So let me also show you that. So these are the structure of how our database is designed. First of all, we represent the entities, means that have some properties. Then we will define the relationships, means how these entities are linked with each other. What is the relationship between all of these entities? Then after that, we merge that relations, that we merge them together. Which relationship should be merged with which entity? And after that, we normalize the relation, means we remove the duplication of data from that entities. Just like here, So this is a small ER diagram. So let's suppose we have an entity employee. I told you that what is entity? Entity can be anything that have some attributes. So just like here, employee is an entity here. Employee can have a birth date, address, name, and employee ID. So these are the attributes of the employee. So in the table, if you remember, I showed you a real database. In the table, employee ID was mentioned, name was mentioned, address was mentioned. Some sort of attributes were also mentioned there. So this is how in a relational table, if we talk about the graphical representation, it will be represented like this. If we talk about the tabular representation, then it will be represented like this. So this is the employee relation in the database, and this is for the visual representation. Now after that we have relationships. So how the relationships are mentioned in the diamond symbol. So I think we have discussed about ER diagram. Does we have we discussed about ER diagrams in previous lecture? So if you remember, then let me know. Otherwise, we will discuss in detail.
No,
So
ma'am, please discuss.
we didn't discuss ER diagrams.
You don't remember. Can you just show us the example?
Okay, no problem. I'm telling you about ER diagrams.
Okay, thank you.
So just like normalization, these are some most important topic like normalization and ER diagrams. So mostly, so I told you that for making an ER diagram, how we can present the entities. I told you what are entities. Entities can be anything that have attribute. So to represent a simple entity, we use this symbol. To present a weak entity, we use this symbol. To represent the associative entity, we use this symbol. So now, what is weak entity and what is associate or what is strong? Let's suppose we have two entities. We have an entity child and we have an entity employee, parent. Now, child only exists if the parent exists, means the child entity is fully dependent on the parent entity. So, if we have a parent entity, then we can say that there is an existence of child entity. Let's suppose we remove the parent entity, then there will be no child entity. If I explain it with more easier example, let's suppose we have two entities, order entity and customer entity. So order entity exists only if the customer orders something. If the customer places the order, then there will be the order entity. If the customer didn't place the order, then there will be no order entity. There is no existence of the order entity. So we can say that the order entity is completely dependent on the customer entity. So now here the customer entity is a strong entity and the order entity is the weak entity. So that is the strong and weak entity. Now the third type of entity is the associative entity. Now what is associative entity? Now it is a type of entity that links two or more entities. Now let's suppose award. Now award can be given to a scholar and to a researcher. A researcher and scholar to different entities. So award can associate a researcher and scholar together. So that is called the associative entity. So it is not mostly used, but mostly the strong and weak entity is used. So this is the first step of the ER diagram, that what are entities and what is the symbol used for entities. Now after that we have attributes. Now, what is attribute? I told you that attributes are the properties of the entity. Like, let's suppose if we have a person, if we have an entity student, then what are the attributes of a student? We have name, ID, age, gender, address, marks, score. So these can be the attributes, the properties of that entity. Now we have different types of attribute. We have a simple attribute, we have multi-valued attribute, and we have derived attribute. So simple attributes are just age, name, just like this. Now, what is multi-valid attribute? Just like as a student, you have multiple skills. Like till now, let's suppose you are also a web developer, you are also a good graphic designer. you are good a language translator. So these are your skills. Means you have multiple skills, multiple properties. So what are multi-valued attribute uh, that can be further classified? So you have multiple attributes, not one, more than one property. So such kind of properties, for a good example of multi-valued attribute is skill. A person can have more than one skill. So that is your multi-valued attribute. After that, we have derived attributes, the attributes that are dependent or derived from the other thing. Now, let's suppose, for example, just like date of birth, we don't know what is the age of a student. Instead of age, the student mentioned uh, its date of birth. Okay. Now, here, the age is derived from the date of birth. Means only that student mentioned the date of birth. Through the date of birth, you drive the student or calculate the student age. So that is a derived attribute. Now after that we have relationships. Now what are relationships? Relationships are used to connect or relate two or more entities. How one entity is related to the other entity. So these are the relationship. So this symbol is the identifying relationship. Means if we want to connect a weak entity with a strong entity, then we use this symbol to represent that is a weak entity. To represent a simple relationship, we use this symbol. This symbol will use the simple relationship. We have different types of relationship. We have binary, unary, and ternary. If our entity depends on itself or the same type, then we use unary relationship. Like for example, a teacher works with other teacher. Now teacher is a person which is working with the other person. So that can be a unary relationship. What is a binary relationship? That relates the entity of two different types. Like we have a teacher entity and we have a student entity. What is the relationship between these different types of entities? A teacher teaches the student. So now the teaches is the relationship between both of these two entities. After that, we have ternary relationships. Now, what are ternary relationships? A type of relationship that connects entities of three different types, that relates entities of three different types. For example, we have a student, we have a teacher entity, and a department. So, a teacher teaches the student, and let's take a more easiest example. We have a project manager, we have a developer, and we also have a graphic designer. All of these three persons are working on a same project. So working on a same project means these three are connected with a same thing. So such kind of relationships are known as the ternary relationships. Now, relationship cardinalities. Now, what is it? It is another important thing for designing the ER diagram. That shows that how many number of relationships are there. Like, for example, we have two entities, student and teacher. So we will discuss it later. So let me first show you with more examples. We have discussed the attributes. So we have also different types of attributes. Composite attributes are the attributes that can be subdivided. Just like if I say that name is the attribute of a person, but name can also further divide it, like first name, middle name, last name. If we take another example, like address. Address can be further divided. What is the street number, which city, which country, house number. So attributes that can be split into further components then such kind of attributes are called composite attributes. Now, after that, we have single valued, multi-valued. We have discussed about that, and we also discussed about drive attributes. Now, most important thing here, we have identifiers. Now, what is identifier? Identifiers are the unique attributes, like that will uniquely identify an entity. Just like, for example, your roll number. You can only have a single roll number or your registration number. No one can have same registration number. Everyone have a unique registration number. So these are known as identifiers. Identifiers are the attributes that uniquely identifies an entity. Okay. So we have now these identifiers can be used as primary key in database tables. So the and how we show them? We underline those attribute, that is we use as an identifier primary key or a unique attribute. We only have a single unique attribute. We cannot have multiple unique attributes. So then we have discussed about entities, then relationships. I told you that we have three types of relationship: unary, binary, and ternary. So in unary relationships, I told you that only one entity is related with the one other entity. Then in binary attributes, I told you that two different attributes are related with one another. A chairman runs the department. Department is another type of entity, and chairman is have another type of entity. So what is the relationship between department and chairman? A chairman runs the department. So if we talk about, we have two more entities like country and president. A country has president. So this is how the unary relationship is presented. Then after unary relationship, we after the binary relationship, in binary relationship we have three types of relationship. One to many means one entity is related in multiple form with city. Let's suppose in a state we have multiple cities. So this is a one to many relationship. Means how one entity is related with other. This is shown by the relationship. Means a state can have many cities. To represent the many cities, we use this crowfoot symbol. This symbol is known as the crowfoot symbol. That is used to represent how a relationship is related with the other entities. Now let's take another example for one to many relationship. Just like a college have many departments, but many departments can be belongs to only one college at one time. So this is a one to many relationship. After that, we have another type of relationship, that is many to many. Means multiple entities are connected with multiple or related with multiple entities. Just like, for example, many students can study the same course, and same course can be studied by many students. For example, now let's take a simple example. Maths is a common subject or course that can be studied by multiple students. Not only one student in this world is studying math. There are millions of students who are studying maths daily. Similarly, students can study many courses. Many students can study math, and math can be studied by many students. Means this is a many to many relationship. Means both entities can be studied by many students. Means in multiple ways they are connected with each other. Now, just like employees and skills. Just like you, let's suppose you are an employee. Can you learn only one skill? You can have multiple skills, like you are a graphic designer, you are also a good developer, you are a good teacher. So these are your skills, multiple skills, not only one skill. Similarly, multiple skills can be studied by one person, means there are 5 or 6 skills that will be learned by a single person. So this is a many to many relationship. Then ternary, I have already told you about that, a relationship that connects three entities. That is a ternary relationship. Then I told you that we will talk about the cardinalities later. Now, what is cardinalities? Cardinalities are the degree of relationships. Means how many number of relations are allowed for one entity. Means first one is the mandatory one. If only one, there is only one relation with the other entity, then we use mandatory one. For to represent mandatory one, we use this symbol. Then we have mandatory many. Means it can be one or it can be many. For optional one, we use this symbol. For optional mandatory, we use this symbol. So we have minimum and maximum values of this. So in year diagram, we have to represent the minimum and maximum number of relationships entity can hold. So that is known as cardinalities. Just like here. Now a student and books. So a student can study no book, but a student can also study many books. So this is the minimum cardinality, then the maximum. First we represent the minimum and then we represent the maximum. Now, let's suppose you are a student. Maybe one day, today is your weekend and you are not studying a single book. So it is possible that you can not study a single book or you can also study multiple books. So this is your relationship with books. You can even study one book or no book or multiple books. Okay. Now, what is the relationship with book? What is the relationship of book with student? It is possible that now you have your own book. At a single time, only one student can study that book, or maybe it is possible that subject is very boring or no one choose that subject to study. That book remains idle for the full day. So that is the minimum and maximum cardinality. First, we represent the minimum. Like here we have the minimum cardinality and this is the maximum cardinality. This is the maximum cardinality and this is the minimum cardinality. Means how many relations are possible with that entity.